In this lesson, we are starting the idea of systems of equations, so where we would have two equations. Our first type we're going to talk about is the quadratic and linear. So again, the quadratic equation is our parabola here, where we have x squared, versus our linear is just our good old, like our back to y is equal to mx plus b, so where you just have x. So we're going to have again, and we've talked about this, like with our quadratics, we could have three different types of situations. We could have whether they never cross each other, so then there's no real solution. They only cross at one point, so this is one real solution. And if they cross at 2 points, then this is two real solutions. So again, like here, for example, here is already a parabola, so a quadratic, what's in red, and then a linear, that here, straight line. How many solutions does this system of equation have that's been graphed? Two, right? Here and here. The solutions are the coordinates where they cross. So 20, 1600, and 65, 2275. All right, 2275. So this is two solutions, because then eventually you'll be able to use this when solving application problems. So like here, for example, this is talking about revenue and the cost for creating the bikes, and we're using the graph to determine when they break even. So again, this idea of when they break even is when they're equal to each other, which is if you were to graph these two equations that are given to you, where do they intersect? So there are two solutions, two where they would break even. So here at 15, 1,275, and here at 60, 2,400. So again, using this idea with the two equations to identify where they would break even. So it's where they cross. So we're going to again use Desmos. So if you ever need to pause the video to practice the graphing, make sure to do so. So go ahead and we're going to graph this. So if you need to, pause and graph it. And so here, when you graph this system of equations, you should get something like this. So you have your quadratic, you have your linear, and notice there are how many solutions? There are two real solutions. And those two real are -3, 7 and 1, 3, where they cross. So go ahead and pause the video here and try and graph these. And in Desmos, you should have seen this. Well, notice how they don't cross each other. So that means how many solutions? There are 0 real solutions. Go ahead and pause the video and try and graph 1C. And here you go. So it should look like this. So notice how it's like they're touching, but they only cross at the 1 point. So that's why here, sorry, there's only one real solution. And that one real is 1, 5. So go ahead and pause the video and do the same thing here. Graph in Desmos and let's see what you get. And so here for the first you try, when you graph, it should look like this. So how many solutions does this represent? 0. No real solutions because they never intersect. So notice here and zoom in, zoom out, but they will never intersect. So you should have said that this was a no real solution. For the second system of equations, when you graphed in Desmos, should look like this. So now how many solutions are there? 2 real. So here and here. They cross at these 2 points at 0, 1 and 2, -1. So this system had 2 real solutions at 0, 1 and 2, -1. And for the third U try, when you graphed in Desmos, you should have gotten this. And notice again how many solutions? 2 real, because they cross at 2 points, 2, 3, and 4, 7. So again, there were 2 real solutions at 2, 3, and 4, 7. So if we were to have just a quadratic system where we have 2 quadratic equations, the 2 parabolas, or 2 where it's x squared. Now we have a fourth option. So notice again, if they never cross, no real. If they cross at 1 point, 1 real. If they cross at 2 points, 2 real. Now because we're dealing with 2 parabolas, because before it was a parabola and a straight line. Now that they're both parabolas, if you graph and they both overlap, so like see, it looks like this is one, but if you were to graph the other and it is laying on top of it, they are the exact same, then we have infinitely many solutions because they're crossing at all of these points here. So now we could have infinitely many. So just to show you at least this first example, go ahead and pause to graph in Desmos. And so again, with this system, it's just like before, again, right, where they cross. So when you graphed in Desmos, now my window is like a little zoomed in, right? So don't just go by what you see. Always zoom in, zoom out, move the window. So here you go. I notice now that there are 2 real solutions. Our graph is crossing at 2 points, here and here. So again, there are 2 real solutions at negative 0.5, negative 6.25, and at 4.23.